Welcome back to the Math and Physics Resource Center online from Saginaw Valley State University. My name is Amanda, and today we're going to be looking at Calculus 3, Math 261, evaluating a line integral over a scalar field. We're going to look at the example of the integral within the region C of xy squared ds, where C is the right half of the circle defined by x squared plus y squared equaling 9. First, let's sketch this region, the x squared plus y squared equals 9. So from that, we know it's a half circle, because we're only looking at the right half, and we know it's going to have a radius of 3 because this would be r squared. So we're going to be integrating across this line right here. So let's convert the coordinates into parametric. Let's parameterize them. So if we do that, we know x is going to equal r times cosine t, so it's going to be 3 cosine t. And y is going to be r times sine t, so 3 times sine t. And now ds, we have to do the same. So ds is the square root of dx over dt squared plus dy over dt squared, dt. So if we solved it out for this case, our dx dt, so the derivative of this function in terms of t, is going to be 3 times negative sine t, that's going to be squared, and that's going to be plus 3 times cosine t squared. So our ds comes out to be, well, it's going to end up being 9 sine squared t plus 9 cosine squared t. If we simplify it, we can take the 9 out of the square root and square root it, so we'll have 3 times the square root of sine squared t plus cosine squared t, which sine squared plus cosine squared t is 1, and the square root of 1 is 1. So ds is just 3 dt. So now let's assemble that integral. The integral we're going to be solving is x y squared ds, which if we plug in everything that we got on the previous slide, it's going to be 3 cosine t times 3 sine t squared, and that'll be times our ds, which is times 3 dt. So now that we have this integral set up, it's in terms of dt. So the bounds are going to be in terms of dt, where t is the angle. So in the angles, we're going from, negative pi over 2 to pi over 2. So let's bring out all those. So now we have all these 3's. They can come out as a constant. So it would be 3 to the 4. Well, there's 1 3, 2 3's, and a 3, because it's 3 squared. So negative pi over 2, cosine t times sine squared t dt. Now set u equal to sine t, and du is going to be cosine t dt. And making the substitution is going to make the integral come out to be, with the new bounds, we're going to plug in negative pi over 2 in for sine t. So sine of negative pi over 2 is negative 1, and sine of pi over 2 is 1. And cosine t is going to cancel with our substitution for our du, and sine t squared is going to become u squared, and that's going to be for du. So now if we solve out this integral, it's going to be u cubed over 3 from negative 1 to 1. And that comes out to be 3 to the 4th times 1/3 minus negative 1/3. And that comes out to be 3 to the 4th times 1/3 plus 1/3, which is 2/3, which cancels with one of the 3's. And it'll be 3 to the 3rd times 2, which comes out to be 54. Thank you for watching this video from the Math and Physics Resource Center from Saginaw Valley State University.